theta plus cos square theta equals to 1. Our aim is to eliminate, means remove, eliminate theta. Okay, so square on both sides because we need sine square. So I get x square divided by 4 equals to sine square theta. Keep the sine theta there first. Transfer the 2. That becomes x over 2 square on both sides. In the same way, do you agree cos square theta should become y square divided by 9? Just square them first and then transfer the 9. So we got sine square theta like that, cos square theta like that. But we know from C1 or GCSE, sine square theta plus cos square theta is 1. So we write our last step as that plus that equals to 1. X squared over 4 plus y square over 9 equals to 1. That's how the Cartesian equation should look like. Look for the shape. See how it looks like. So that's how, when you see sine and cos, please listen, you are there. In the same way, if you see tan and sec, it's actually 1 plus tan square theta equals to sec square theta. Question 2, we got sine t, cos t, again exactly same. So make sine t subject there. We have sine t is equals to x plus 5. Agreed? And square it. So if you square, that's what you get. Don't say x squared plus 25, please. It's a whole square. Then we have cos square t is equals to y square. So simply add those two, equate it to 1. Sine square theta plus cos square theta is 1. Therefore, x plus 5 whole square plus y square equals to 1. You can leave the answer like that, nothing wrong. 2-3 questions to go based on trigs. Now this is double angles. Watch again. We have sine theta. That's great. This theta is nothing but t. All right. Cos 2 theta, double angles. Cos 2 theta, right? You can express in terms of sine. Right? It's a 1 minus 2 sine square theta. If you go and check, they are very important. Write them at one place, so it's handy. Now, this is y is equals to 1 minus 2 sine square theta there. What we can do, sine theta is x over 2, right? Transfer the 2 there, x over 2. So when you square this, because we need sine square, we get x square divided by 4. So that's a x square divided by 4. One more step to finish the question. 1 minus x square divided by 4. Okay. It is a quadratic, right? X square over 4 minus, so it's an upside down U shape. That's what you need to do. Okay, so sine and cos 2 theta, double angles, very important. That's a sine and cos, so back to square 1. We have sine square theta plus cos square theta is 1, guys. So that's x minus 1 equals to 2 sine t, and then transfer the 2, square it, you should get the answer. Okay, square, add them, you should get 1. So I will leave that question with you. We have question 5. Let's see. Sec and tan. Important, right? We know 1 plus tan square theta equals to sec square theta. That's what we know. Let's go and find sec square theta from there, the first one. If you make sec theta common, you're supposed to get x minus 2. Right? If it's a sec square theta, that's a whole square. Then from this one, let's make tan theta subject. So we have tan theta equals to y minus 3. Square it, we have a whole square. Sec square theta minus tan square theta is 1 from C3. So we can actually say that minus that. So it's x minus 2 whole square plus, minus. Right, sec square minus tan square. Y minus 3 whole square equals to 1. Nothing wrong if we leave the answer like that. Converting the parametric form to Cartesian. Important facts there. All the trigs one needs to know. That's a cos and sine but I don't have a letter, sorry, the number, but we do have a letter. It is still same, square, and add them, you should get 1. So it should look like x square over a square plus y square over b square is equals to 1. That's an ellipse shape. It's an egg shape, like if you draw the curve. So that's the Cartesian form, please. Right, the question is x equals to 1 plus sine t, y equals to 2 cos squared t. Let's make sine t subject there, see what happens. Sine t equals to x minus 1. And sine squared t equals to x minus 1 whole square. Now, why we are doing this means we can express cos square in terms of sine square. We know that, isn't it? So that's a 2 bracket. Cos squared theta is 1 minus sine squared theta. See, now we got sine squared theta value there. We can substitute. So the answer should be 2 bracket 1 minus x minus 1 whole square. Open the bracket, collect your like terms. That should be the answer. I just want to stop there. We finished the conversion into the Cartesian form from the parametric form. The next few sums are based on the parametric equations intersecting with x-axis and y-axis, and then finding the intersecting points. So it's the intercepts from next question, please. That's what it is, intersection with the x and y axis, and how to solve that type of sums. So basically what we need to do is, this is a parametric equations, I mean 2 of them. There is a Cartesian equation which we don't know yet, and that curve somehow we don't know the shape, right? Where does it cut the x-axis and where does it cut the y-axis, and we are finding the coordinates. That's what it means. So the intercepts with the axes. So the first one, right, we know for x-axis, if a curve cuts the x-axis, do you agree y coordinate must be 0? So I'm going for x-intercept, x-int, right? For x-intercept, we put y equals to 0 in our question. So y equals to 0 equals to t square. So for what value of t, y becomes 0, we need to find t equals to 0 again, isn't it? You all know why I put y equals to 0, because we are finding the x-intercepts. Right, so t is 0. We substitute this t value in x to find that x coordinate. So x equals to 4 plus 0, right? 4 plus t is 0. We got a 4. So the actual Cartesian curve is supposed to cut the x-axis at a point called 4, 0. Sorry. So that's one intercept. Now let's look for the y-intercepts. For y-intercept, we all know that the x-coordinate must be 0. So we go to the x-coordinate here in parametric form and substitute x as a 4. 4 equals to 4 plus t, done, and t is equals to 0. So when, oh sorry, we did it wrong. X is 0, guys, right, 0 there. And t, 4 plus t is 0, so t must be a minus 4. Sorry about that, right? So t is a minus 4. This minus 4, we substitute back in here to find the y. Okay, so y is equals to minus 4 whole square, which is 16. So the y coordinate there is 0, 16, right? Just be careful, I did that wrong here. Watch out how you do it. What we said was, if it cuts the y-axis, the curve, x coordinate is 0. So we make that 0 and find t. When you get t, put that back here to get the y coordinate. Maybe if we do one more question without a mistake, we will understand, right? There we go. We have x equals to t square. Why is that? I'm finding x-intercept first. So I'm putting y equals to 0 to see what happens. Right, 0 is here, 1 minus t and t minus 5. So there are two values for t, please. T is equals to 1 and t equals to 5. So there are actually two places where it cuts the x-axis, right? To find out, we put 1 first. So if t is a 1, then x equals to 1 square, which is 1. So we got a point called x is 1 and y is 0. When t is 5, we put 5 there and we got x equals to 5 square, which is 25. So we have two intercepts. One is 1, 0, the other one is 25, 0. Those are the 2 points where the curve, the Cartesian one, please, cuts the x-axis. Right? We need to see where does it cut the y-axis now. Very important. Question C is here. That's x equals to 2t plus 3, y is a t squared minus 4. We are finding the intersecting points with the axes. Okay. So I'm going to find the x-intercepts first. X-intercept. So we put y equals to 0 to find the values of t. T square minus 4 is 0. T square equals to 4. We also or minus 2, please. Two values there. Sometimes t is greater than 0. Right here, we just keep it like that. Then we need to find the x-intercepts now. So t equals to a plus 2 first. So we have x is equals to 2 times 2, 4 plus 3, 7. So we do have a point called x is 7 and y equals to 2. No, that's 0, right? 7, 0. Happy? That's the t value, please. Then we put minus 2. So minus 2 times 2 minus 4 plus 3, that's a minus 1 and 0. That's 0, please, because we substituted y as 0. They are x-intercepts. Then we need y-intercepts now. For the y-intercept, we put x equals to 0. So I have 2t plus 3 equals to 0, right? And the value of t should be minus 3 over 2. So there is only one y-intercept when t equals to minus 3 over 2. So substitute that here. Y equals to minus 3 over 2 whole square and minus 4. And we can simplify that. That should be a 9 over 4 and minus 4, please. You all know how to do that. 4, 4, 16. 9 minus 16 minus 7 divided by 4. So the point is the y-intercept is x equals to 0 and y is a minus 7 over 4. Okay. Those are the two x-intercepts, but we have only one y-intercept. So the idea is to just substitute x is 0, y is 0, depending on what intercept you are actually finding. X-intercept first, right? I will go for that. X-intercept is, let's go a little bit back, yeah. X-intercept, we put y equals to 0, 0 equals to t plus 4, and the value of t we got as minus 4, please, right? So once we get t as a minus 4, substitute back into this. So we got x equals to minus 4 square, which is 16. 5 times minus 4, so that should be a plus 20 and then plus 6. So that's a big number there. 16, 6, 22 plus 20, 42. So what is the intercept now means? It's actually 42 is the x number and y is 0, please. Do not forget that. Okay, that is done. Now we need to find the y-intercepts. There may be 2 because we can factorize this, isn't it? So let's put x equals to 0. We are finding y-intercept, please. So t square minus 5t and plus 6 equals to 0. Then we solve for that. Factorize, we all know quadratics, they come everywhere. T minus 3 and t minus 2. So we have 2 values. T equals to 3 or t equals to 2. When you get this t equals to 3 and 2, we are supposed to substitute both of them in there to get the y-intercept. So we got y equals to, when x is 3, 3 plus 4, 7. So the point that we have now is actually 0, 7. That's the y-intercept. The next one is y is equals to, substitute 2 there, 2 plus 4, 6. Sorry, the point is now 0, 6. So those are the two y-intercepts, but we have only one x-intercept, please, right? That's how you do these sums. So we have done 3, 4, 5 sums based on the finding the intercepts with the axis, right? X and y axis. So substitute x equals to 0 for the y-intercept and y equals to 0 for the x-intercept. Once you get those values, you can actually find the intercepts, right? Now, the next part is based on a Cartesian equation, and you have the other one. You are supposed to find the intersecting points of two equations, right? That's the next part. It's the points of intersection, very important one, right? That's what it says, points of intersection. That's the Cartesian equation. We are happy. We are supposed to find a Cartesian equation here and then solve those two. There are many ways to do, but let's try this way, right? So change that into a Cartesian equation, please, right? Let's substitute y value, say here. So t is equals to, move the t there, that's a 1 minus y. Now this is what we substitute there, that's easier, all right? So x equals to 3 bracket, t is 1 minus y, and there is a plus 2, okay? Open the brackets, 3 times 1, 3, and plus 2, it's a 5, and minus 3y equals to x. See, now you can easily solve those two. We already got x as the subject here. We can substitute that there or substitute that in place of y. I think that's much easier to do. So that implies, watch there, 5 minus 3 bracket. The y value we already know, which is minus x plus 2. That's it. We open the bracket, please, with a minus 3 there. So that should be plus 3x and minus 6. So we have 3x minus 1 is equals to x on the left hand side. We can solve that now. So minus 2x equals to minus 1, x equals to half. All right. So simultaneously solving them, change this into the Cartesian equation and then solve for x and y. So we got the x value as half. We can substitute there to find y. So y equals to minus a half and plus 2. You know the answer now. That's 1.5, right? Yeah. So those are the two values. Okay, the second question. You want to try, please? Copy that and find the values of x and y. That's the Cartesian equation, but this is not. So we need to change this into Cartesian, please. So if I make t subject, we are in trouble because we have a square root. Rather make t subject here. Let's see what happens. T is equals to, we have y minus 3 and divided by 3. That's what we can substitute in place of t there, right? So x equals to 2t square and minus 1. That's a y minus 3 over 3. That's the value of x. You can actually substitute directly that there to find the value, but let's simplify it a little bit to see what happens. 2 stays there inside the bracket. That's going to be y square minus 6y and plus 9 divided by 3 square is a 9 and it says minus 1. Okay, once we got that, then we can open the brackets. So it's 2y square divided by 9 minus 2 times 6, 12y divided by 9. Then we have plus 9 times 2, 18 divided by 9 is actually a 2, right? So actually 9 will go away. 2 and minus 1, so that becomes a 1 there. Okay, this is the value of x, please understand. So this is what you're going to substitute back in there to see what equation we get. That's a 4y, 3x minus 3, please, right? Let's do that here. Simultaneously solving, you can do that later because I'll just show the steps to you what to do. So 4y is equals to, watch that, 3, and this whole thing comes inside the bracket because that's the x value. 2y square divided by 9 minus 12y divided by 9 plus 1. That's what we have, and there is a minus 3 as well. Okay, minus 3. So let's write that minus 3. Simplifications, very important, and be careful how you do them, right? Let's see, we got 3 goes there 3 times, so it's a 2y square divided by 3, and minus 3 cancelled, 3 4, so that should be a 4y, and plus 3 times 1 a 3, watch there, minus 3, lovely. Those two, sorry, we are off the screen. Yeah, those two are gone. Left hand side is a 4y, please. Now that is a quadratic. You can actually take the LCM. Let me do that here. Take the LCM, please. So times by 3 all the way. 3 times 4, 12. 12y is equals to 2y square, and times by 3, that's a minus 12y. Take the terms to left hand side or right hand side, doesn't matter. 2y square minus 12y, take that 12y, so it should be minus 12y equals to 0. Lovely equation we got. Divide by, this is 24 and 2. So if you divide by 2, you are supposed to get y square minus 12y. That's a y, please. 12y equals to 0. Because we took 2 common, right? And factorize this, y bracket, y minus 12. So y equals to 0 or y equals to 12. When you get these two values, you can substitute them here to find x value. Okay, so I will leave that with you, please. That's how you solve these sums. Change that into Cartesian form and then solve those two simultaneously. Simultaneous equations you all know, so I will leave that with you. The next question is here. Looks like that's x square y square. X equals to t square, y is at 2t. We can do this like let's take t as the subject. So t equals to root x there. Substitute back into this. So we got y equals to 2 root x. That's all. This is what you substitute in place of y. So what do we get, sir? Means we get x square as x square. Y square should be, you square that, it's a 4x. Plus 4x minus 9x and then plus 4 equals to 0. A lovely quadratic. X square is x square. That's a minus 5x and plus 4. Beautifully done, because we are happy here. The factors are there. So it's x minus 4, x minus 1. That makes sense, right? So we have two values for x, please. X equals to 4 and 1. These two values, if you substitute here, we should get y. So y equals to 2 root 4. So that should be a 2 times 2, 4 there. Then we have the next one, y is equals to 2 root x, so 2 root 1, which will be a 2. So two values for y and two values for x. That's how you solve them simultaneously. The next one, please copy that. Last one, this is then we do differentiations of the parametric equations. X plus y square equals to 9. That's the Cartesian equation, please. So I can do nothing. I can leave it there. And we are supposed to do the second bit here. That's a square. Making t will be a little bit subject. Okay, doesn't matter. It's a y over 2. No. Let's make t subject here. That makes more sense to me. Transfer the square first. Root x equals to t minus 3. And t equals to root x plus 3. That's what we have. Substitute that back in there and we are supposed to get the Cartesian. Y equals to 2 bracket root x plus 3, and that's going to be y equals to 2 root x and plus 6. That's one equation I have. This is what I can substitute in place of that, and we can find the values of x and y. Okay, just be careful how you do that. That's a square, please. So we are supposed to square it. Let me do that here. Let's square this.